All right, nice to meet everyone. As I was saying, I'm Raza. I'm one of the co-founders of Human Loop, and I want to talk a little bit about the pitfalls and best practices of putting LLMs into production and trying to build applications with them. Before I kick off, is it okay if I get a little sense of the audience? Like, who here is from academia? Okay, mixed bunch. Who here has put an LLM into production? Excellent. And anyone not working on information retrieval? Okay, so quite a diverse group. Okay, great. I think this will be a good mix. So maybe to start with, like, why am I qualified to even talk about this? Like, why can I come and tell you guys about the pitfalls and best practices of putting LLMs in production? So I'm one of the founders of Human Loop, and we've been, for the last year or so, we've been working on a platform it's a developer tools to help people find the best prompts for LLM applications and to evaluate and measure the performance of their systems in production. And so over that time, we've worked with a lot of different companies, from like really large ones like Duolingo to like startups who are trying to do very cutting edge things. And we've seen a lot of things work. And we've also seen a lot of things not work, right? I mean, everyone's trying a wide variety of possibilities. And so from that, what I'm going to try and do in this talk is distill some of the lessons that we've come from then, and hopefully help you avoid the pitfalls and do the things that do work a little bit more. So before I kind of dive into pitfalls and best practices, I just find it's helpful to have some kind of concrete application in mind, and also to dwell on just some of the applications that we have seen in the last couple of years since large language models really just took the world by storm. So I had a go at just giving myself an exercise a few weeks ago. How many could I write down in 5 minutes? So there's a lot more possible applications than this, but this was just like a very quick brain dump. But we have everything from improved code search. So we've got Bloop and Cursor and Find and GitHub Copilot, marketing writing assistant, sales email generation, a lot of information retrieval applications. I'm not going to read all of these, but the point is that the range of use cases for what is a very similar technology has become absolutely vast. For each one of these use cases, you could probably come up with a handful of companies that are just targeting that one use case, but all building on really, really similar foundations and similar technology. But as I say, I like to have one kind of concrete use case in mind that is an example that we can all hang our hats on. And one of my favorite LLM applications that I think is a really good example of doing this right in production, and very successful, is, this works, GitHub Copilot. So I'm going to try and, like, throughout the talk, try and sort of litter some real world case studies of real products or services that build on LLMs throughout. And the reason I like GitHub Copilot is I think it was a big UX innovation. It also is just one of the most, like, successful by numbers application of LLMs, right? So it very quickly reached 1 million users. Developers are a difficult crowd to get adoption from, especially when you're trying to get them to adopt a new dev tool. And I also just think it gets a lot right in terms of how they made it both work well and be defensible. So going to kind of dig into the structure of an LLM app in general, and then GitHub Copilot in particular. So, I think of large language model applications as having all of the normal things in applications that we normally have, right? The majority of this lives in code, but then there are what I think of as LLM blocks that can be used as part of agents or chained together in part of the code. But essentially, an LLM block is some prompt template, a base model. It might be fine-tuned for the task, it might not. And then some way of filling the template, right? So that the way you fill the template might be from user input. It might be retrieval augmented generation. It could be a tool or a function call that, with OpenAI functions that's retrieving the input. But fundamentally, like, you always have these three components. And when you're trying to get the LLM part to work well, you're really thinking about, how do I improve each of these three parts, right? Can I have a better fine-tuned model? Like, can I improve my prompt template? Can I improve the strategy that I use to populate it or do the data selection? And in the case of GitHub Copilot, okay, I just got to press this twice every time. You thought I would have learned by now. In the case of GitHub Copilot, right, they have a custom fine-tuned 12 billion parameter model. So they spend a lot of time thinking about what is the right base model to use. They fine-tuned a model on code. So this was OpenAI's Codex model. You'll notice it's a lot smaller than the best models, because the way that they chose to implement this is it works as a text prediction model in your IDE. And so latency is really important. You can't be sitting around waiting for seconds to get a prediction. It has to be almost instantaneous to be useful. The strategy that they use for building the context of the model is quite complex, but still very rudimentary. Like, there's a long way to go. This was the first attempt, but what they do is they chunk your code base of the recent files that you've touched. So they always keep a kind of running memory of what are the 10 or 12 most recent files you've touched. They take the code immediately behind your cursor, and they literally just do an edit distance check. So not even cosine similarity. They're just checking, because it has to be really fast, like what has the highest edit distance overlap with the text that's immediately behind your cursor, and they're feeding that into a structured prompt and then trying to suggest code going forwards. So clearly a lot of like thought went into actually how do we even just do the right form of retrieval for this. And then I think the thing that I find one of the most overlooked parts of this, but one of the most interesting parts, is how they do evaluation. And I'm going to go into that in a lot more detail slightly later in the talk. But I think the reason that GitHub Copilot was such a big success, and the reason they managed to get the model to be so good, is actually because of how carefully they thought about evaluation and using that to consistently improve the system over time. They were by far from the first attempt at doing using large language models or AI to do kind of completion for code. Tab9 and many other companies had done it before. Yes, they had a distribution advantage, but I also think that they did some really clever stuff. And given that evaluation data, then they regularly fine-tune this network. So it gets better and better at this task over time. And so now that we have like a concrete example, I'm going to try and refer back to that example as we go throughout the rest of the talk. But I'm going to sort of split my talk into there's going to be three main messages that I think are worth taking away if you're building production applications with LLMs. But yeah, sorry, I lie. First, I just want to talk about why it's hard, and then I'll talk about the three main messages. So like what makes building LLM applications more difficult than even traditional machine learning or just software in general? So for me, the first one is that evaluation is just much, much harder. So you no longer have a correct answer. Like everyone here is from a machine learning background. So we're used to code being stochastic, but we're also used to having ground truth. You have annotations, you calculate an F1, you calculate precision, recall, whatever it might be. But what's the ground truth answer for whether or not a sales email is good if you're generating that for someone? The use cases that we're thinking about now tend to be a lot more subjective. And in some sense, the correct answer is whatever your user says the correct answer is, in which case it's much harder to kind of have a concrete evaluation during development. Prompt engineering has a really big impact on performance. We saw from the initial talk that it's a big part of research these days, and yet it's still a bit of a black art. It's hard to know how to make changes, and because evaluation is hard, this remains hard as well. We talked about hallucination, so I'm not going to spend too much time on that. And then once you've got a third-party large model that you're sending your data off to, you introduce questions around privacy, latency, and cost that maybe you didn't have before when you're running small local models. And so you have all these extra constraints. And then people who are building stuff in production applications also worry, like, what's going to differentiate this? Can't someone else just stick something around GPT-4 and do the same thing? So thinking a little bit about how to go beyond a thin wrapper around GPT-4. And hold on, I'm just sorry, checking. Okay, something has gone wrong with my talk slides, but I'm going to carry on and hopefully it'll resolve itself. Yeah, so the kind of three main things that I want to talk about, and things that I see people getting, like when they get these right, they tend to have successful applications, and when they get them wrong, they tend to spin their wheels a lot. The most important one by far, if we were going to take away one thing away from this, I would say is like spending a lot of time up front thinking about evaluation and having a framework in place for doing that. Otherwise, there's so many moving pieces. The second that I think is somewhat counterintuitive is actually taking the management of your prompts and the versioning and the collaboration on them like really seriously. Effectively, these are now part of your code base, and yet people, for some reason, don't give them the same weight as they would to code, but they have a really big impact on your performance. And then finally, like a lot of underestimating the power of fine-tuning. I think especially because a lot of people very heavily use Cohere, Anthropic, GPT-4, and not all of those until recently had fine-tuning APIs. So fine-tuning being neglected or underestimated in its power. So I'm gonna kind of take those in turn. So the first one, sort of why objective evaluation is essential and how you might go about doing it well. So I've already talked about why it's hard. It also just matters at every stage of building these apps. So, when you're prototyping and you're trying to iterate on the first components of your system, the retriever, the prompts, just trying to get to first results, not having any quantitative metric about whether or not things are working means that you spin your wheels and you try lots of different things. You don't know, are you making it better or are you making it worse? Hard to say. Then once you're in production, you typically get a range of inputs from your users that are much broader than what you anticipated when you're developing this. It's very hard to have a representative input set. And part of that is because foundation models are so general in what they do that the applications now are very, very broad. And when the application is that broad, the distribution of inputs ends up being much broader. And then the final sort of part where I think evaluation ends up being really important is, okay, you did the prototyping stage, you kind of got something into production, you're monitoring it, you know it's working reasonably well, but then you need to make changes. A new model comes out, you want to update the retriever, you want to do new embeddings. How do you know that you're not making things worse, especially when evaluation is so subjective? And objective academic benchmarks can be really misleading, right? So my favorite example of this is in the Helm benchmark, which was the Stanford Holistic Evaluation of Large Language Models. They noted that the ground truth summaries on the CNN data sets that are used for summarization, humans preferred the model-generated summaries to the ground truth. So if you hadn't gone and done human evaluation and you just relied on the annotations that were in that test set, your conclusions would have been anti-correlated with the correct answer. It's really hard to evaluate these things well. So what are some of the common mistakes that I've seen people do in practice? Well, the first is just like not having a systematic process around evaluation. This is remarkably common. Because it's so difficult to do, people eyeball a few examples and then they YOLO it into production and they hope for the best. And like, that's okay if you're like a 4-person startup, maybe. You can learn in production, but maybe not if you want something that's going to work really reliably. Then the next is when people do set up evaluation, they don't set up evaluation that looks at every part of their system individually. So like, gone are the days where we're just sticking a prompt into GPT-4 and waiting for an answer. We've spent a lot of time talking about retrieval augmented generation today. We've also spoken about function calling and tools, and your wider application impacts the quality of the LLM parts. And so you need some way to both understand the impact of your prompts and the LLM and those bits, but in the context of a wider application. And then I actually think that people should start thinking about evaluation at the time that you're designing your product. So you can actually make decisions in the design of the product itself that will make evaluation easier. I think GitHub Copilot's a great example of this. There's a few others as well that I'll talk about. And then I also just think that like, use the right tools for the job. Like don't try and shoehorn this into something like just dumping logs to a file or using Mixpanel, because you can't triangulate the analytics data you have really easily well against things like what was the embeddings I used, or what was the prompt, or what was the model, and the iteration cycles just tend to be really slow. So what happens when people get this wrong? The most common thing I see is actually people just give up. They try something and they don't try hard enough, and they're changing loads of different things, but they don't know if it's getting better or worse, and they conclude it's not possible. And I have seen, because we have multiple companies doing similar things on our platform, 2 different teams, one who had good evaluation, get amazing results, and the other conclude that GPT-4 couldn't do the task. And the only real difference was how much time they spent on evaluation. And then, yeah, spinning your wheels is like the most common issue. And I was sort of corresponding with Alex Gravely about this, who was the developer or the lead product manager on GitHub Copilot. And he said to me, in his view, baseline evaluation needs to be the core of any AI app. That if you don't do this, I think he said something along the lines in a talk once that he doesn't think you're serious if you haven't done this. So how does GitHub Copilot do it? Because it's kind of a good prototype for others. So I think that end user feedback is like really priceless in evaluating these things. You want other sources of objective feedback as well, but especially for subjective use cases, what do your users think about the results that they're getting? So in the case of GitHub Copilot, what they monitor is what is the acceptance rate of suggestions and what fraction of that accepted code stays in the code base at various time intervals after. So it's like a really strong proxy for how good is this model, right? And I put these numbers down. I don't know, actually, they're in their code base. I don't know where they came from, 15 seconds, 30 seconds, 2 minutes, and 5 minutes. Like, why those time intervals? I don't know. But it's indicative to me of like having done a lot of work on trying to get this evaluation right, that they're not just looking at the acceptance rate, but actually looking at something a little bit more nuanced than that. So end user feedback, when you can get it, and if your app supports it, is really great. The best applications I've seen do some mixture of both explicit and implicit end user feedback. So a lot of apps you'll see, like ChatGPT has these thumbs up, thumbs down buttons. They're okay, but you tend not to get a huge amount of user feedback from that. It's a little bit biased. But there's a company that I quite like, Pseudowrite. They would build a fiction writing assistant for novelists and other writers. And in their app, they have all these extra actions that users can take: insert, copy, generate, thumbs up, thumbs down, etc. All of those are linked to signals of feedback, and they use them as sources of understanding how well things are working. Similar with Find is a company I'll talk about in a bit. And there's usually signals you can gather in your application that tell you, did the user achieve the goal they were trying to achieve? The other thing, yeah, so roughly speaking, in Human Loop, we kind of by default having 3 categories of user feedback: actions, what do they do? Votes, thumbs up, thumbs down, other things. And then corrections can be really useful if you're doing a writing task or something like that. So a form of writing assistant, then actually getting the right answer for fine-tuning can be super helpful. I'm going to keep looking over here, by the way, to help me keep on time. Just rush me along if I'm being too slow. And then the final sort of thing beyond kind of like, beyond sort of feedback that's coming from the end users is I think you obviously can have some amount of automated feedback. You can calculate some of the traditional machine learning metrics we're used to, Rouge scores, those kinds of things. Increasingly, we're finding people use LLMs themselves as part of the evaluation, but you have to be really careful about how you do this. So we constrain it such that when people set up LLM evaluators on a human loop, they're only answering binary questions or returning a float. And we encourage people to ask questions that are kind of factual about the inputs and outputs. Was the final answer contained in the retrieved context? Yes or no? Those kinds of questions, those can do quite reliably. If you ask kind of very generic, vague questions about quality, you tend to get a lot of noise in your evaluation. Noisy evaluation is almost as bad or worse than no evaluation. But it can be extremely helpful. Okay, so I'm gonna speed run the last two. So I talked a lot about evaluation. I think it's the most important one. The next one I would just say is like the importance of prompt management. So a lot of people we see do prompt engineering in some form of playground and Jupyter notebooks and Excel code. They copy paste things to GitHub to deploy it. It's not properly versioned. It's difficult to collaborate between the technical people who are the engineers and maybe the domain experts or the product managers who might actually have lots to add when it comes to prompt engineering. And so if you do this, like common things that we see is people do a lot of experimentation, but they don't track it. So they're building up all of this implicit knowledge about what does and doesn't work, and then they throw it away. Or they don't accumulate those learnings. They try the same things again and again. We saw a company do the same annotation task twice because two different teams didn't know the other team had done it. And also we see a lot of people rolling homegrown solutions for this, but in a way that kind of doesn't, it's pretty myopic. They kind of solve the problem immediately in front of them and they end up with a bit of a Frankenstein. So, I would obviously sort of recommend, and I also would say, like, don't underestimate the impact this has. People have mentioned here, like, chain of thought as a kind of, prompt technique that has a big impact on question answering. DeepMind published a paper last week where they did a big search over automated search over prompts and found that they could do much better than humans if they sort of used it very well. But the point is that, like, the prompt is now part of your application. It's part of the code. It needs to be treated with a degree of seriousness, even though it feels superficial, right? Like before we used to annotate a data set and fine tune a model and it was a lot of work. And so it had a gravitas to it. We just wrote a prompt, feels like it wasn't a big deal, but it's having a big impact on your application, right? And so I think you should give it some seriousness. And we've already talked about retrieval augmentation, so I'm going to skip past that. But yeah, I don't think it matters what solution you use, but I think you should have some form of like way to manage your prompts that versions everything, that like keeps track of what the results were against evaluation data. And the other mistake we see is a lot of people use Git. Git feels like it's a good solution for this. And it is part of the solution, right? It's text in code. Like, why don't we version it with Git? The main friction point that I've seen people have with that is it's very common to want collaboration with non-technical people. And it's just hard to do that when everything lives purely in Git. So I would say you want both, ideally. Okay, last one is just don't underestimate the value of fine-tuning. It's hard to get better performance than GPT-4 or like the state-of-the-art models, Anthropic or Cohere or whatever, but you can get significantly increased cost and latency. And also you can get private models. And a really common design pattern that we've seen, I'm going to skip past this, is that people generate data with the highest quality model they can get. They use their evaluation feedback, whether that's coming from objective sources or end users, to filter the data set in some way. And then they retrain, and they can often run this multiple times with continuing improvement. And this is actually the cycle that Copilot runs as well. So Copilot is regularly fine-tuning on the data that's scored highly from their in-production application, which gives you a flywheel as well that potentially allows you to become better in your domain than others. I've got 1 minute left. And so Fine is an example of this. This is a company that does search over code, essentially, and question answering. And they recently fine-tuned Llama, and they do outperform GPT-4 on human evals. And the reason they do it is they have 70,000 question-answer pairs with feedback from in production, and they filter on the ones that they know are good. And so I would kind of conclude that fine-tuning is the other one that I think often gets underestimated. So, Human Loop is trying to build a platform that makes these things easier, particularly around prompt management and evaluation. And it's inspired really by the lessons from doing this in production for quite a long time with a lot of different companies. And that is my last slide.
Perfect. Thank you for the talk. You handled the time great. Let's start with the questions. Yes.
Hi, thank you for the talk. It's very interesting. I think evaluation is also very important and very essential and often forgotten. I was wondering about, with evaluation being so central, do you also think that evaluation as it's set up with, like you said, implicit and explicit user feedback with a ground truth labels that are maybe sort of designed, does that need very different expertise maybe than the sort of expertise that is in sort of traditional ML pipelines? And how do you find or create such expertise?
I'm not convinced that the expertise itself is super different. It's still thinking systematically through how do I measure the performance of this system. I think what's different is that most of the metrics that we're used to be applying just don't apply because we don't have ground truth, or two, there just isn't a ground truth answer.
But the expertise, so I work a lot in my project, for instance, with social scientists, and like how you design, for instance, feedback buttons or feedback. Those are things that matter a lot. Yes. And like you don't get that from sort of
okay, I think I understand your question a little bit more now. In that case, like, yes, I mean, one thing I would say is like something that I've seen in the 3 years that we've been working at Humanloop, that as large language models have kind of come to the fore and started to dominate AI applications and NLP applications, the types of people who are building them has changed dramatically. So whereas maybe 3 years ago, I was only speaking to machine learning engineers, typically today, the majority of our customers are generalist software engineers and product managers, and they're often bringing in a lot more domain experts into this process. So we have like, both like linguists, but I mentioned like Duolingo on there earlier, right? So they have like content creation experts within the company who are involved in this as well, product designers. So partly you need the expertise, and also I think the accessibility means that it's easier to get more stakeholders involved.
Okay, thank you.
Thank you. Building on the previous question also with the compliments, evaluation. So a lot of what you said is absolutely true, but it also absolutely true for other domains. Like if you talked about information retrieval, then a lot of those concepts come back. And I was wondering if you can highlight what do you feel is specific to transformers or large language models that you should absolutely do if you already follow practices for software development, product development, retrieval model, these type of things. So what makes this specific domain more powerful?
So I don't think it necessarily needs to be more powerful. I think that the challenge is somewhat exacerbated because of how general the outputs are, right? So both the long tail of use cases means that the difference between your test distribution and your training distribution is often a lot bigger than you're used to, right? Like we talk about domain shift or things like this when we go from training to test. You almost guaranteed domain shift because your domain is so broad. And also, it's much harder to evaluate ground truth. I gave that summarization example, right? Because the models are outputting correct answers in so many different ways, like scoring whether it's correct or not is just harder than it was before. So I don't think it's discontinuous with what we had in the past. I just think that compared to what we had, it's become a lot more difficult.
Great. Let's thank the speaker one more time. Oh, we have a question online. Okay, if it's quick, we can do it.
Hi, question
Hello to people at home.
Aditya Kaur online. Have you worked in integrating large language models into industries that might have existing AI, ML, or data science groups? Are the challenges and pitfalls the same? Any thought of LLM ops?
Yes, so we have almost all of the companies we work with have both, and there's some collaboration across teams. One thing that I've seen is actually the companies that have a lot of ML people are often slow to accept that LLMs are better at the task. Like they will eventually get there, but like they're reluctant in a way that maybe I think actually teams that start with software engineers are less so because they're less threatened by it. But usually it is a collaboration of both, and I think especially as fine tuning becomes more important, and there are more good quality open source models, I think we'll see a little bit of a resurgence of the ML skill set becoming more relevant.